This time, I'm going to talk about building a life expectancy trends ARIMA model in Python. I used this paper as my reference and data source. Let's take a look at the paper first. This is the paper I used for the reference. You can see in this paper there are a lot of tables, and also they did some trends and projection analysis. This paper is available to download from the internet, so if you are interested in reading this paper, you can download it and read it by yourself. In that paper I just mentioned, the study focused on mortality projections and life expectancy for the US Social Security area. Basically, in the paper, they have the study area from 1900 to 2100. And they performed analysis of life expectancy and mortality rates based on period and cohort life tables. Of course, they have their own model. Instead of figure out what kind of model they used, based on the data they provided in this paper, I performed my own analysis of life expectancy based on period and cohort life tables. This is the overview for my ARIMA model. My goal is forecast life expectancy using ARIMA on calendar year and birth cohort data. ARIMA model considers past data to predict future trends in life expectancy. The model helps estimate life expectancy in future years. I did up to 2023 because this is the last year I can get the actual data from the internet, and it uses historical data to predict and compare with actual outcomes. In my model, first I will load the data from two key data sets. One is calendar year, another one is birth cohort life expectancy. And I did data clean, and I normalized it and indexed for use in my ARIMA model. The model supports setting parameters like cohort weight, train, and forecast years. In my model, I processed data for both male and female life expectancy across different age groups. I pick up age 0 and age 65. Of course, you can pick up other ages. And I will upload my program and also my data file to my GitHub. You can download them and maybe do some your own research about other ages. Now, let's take a look what's the difference between these period life expectancies and cohort life expectancies. Period life expectancy is the average number of years a person would live if they experience the age-specific mortality rates of a given period, usually 1 calendar year, throughout their entire life. Period life expectancy uses all actual data. It is calculated based on the actual mortality rates observed in a given calendar year or period. That means when we talk about this period life expectancy, it will consider, for example, in 2024, how many people passed away. So we can collect all the actual data. In the meantime, this cohort life expectancy is the average number of years a group of people would live, taking into account the actual mortality rates they will experience throughout their lives. For past cohorts, cohort life expectancy uses a mix of actual data and modeled data. The actual data reflects the mortality experience of that cohort up to the present. However, modeling is required to estimate future mortality rates that the cohort will experience as they age. That is saying, for example, if we consider the group of people who were born in 1950, some of the people who were born in 1950, they passed away already, so we have the actual data. But for other people, they are still alive. So we need a model to estimate when they will pass away. That's why this cohort life expectancy, all those data is kind of mixed. It's not actual data. For my model, I have a parameter here. If we say we use combined data and the cohort weight is 0, and that means we only use this period life expectancy data. If we say cohort weight 0.5, that means we use 50-50 blend between calendar year and cohort values. Then we will do the model fitting and the parameter selection. ARIMA model order P, D, and Q were selected based on AIC or BIC criteria. A search process iterates over possible parameter combinations to find the best fit. The model handles time series data considering stationarity and invertibility constraints. For each dataset, the best parameters are identified for accurate forecasting. Once fitted, the model forecasts life expectancy for future years. As I mentioned, it's up to 2023. And forecasts include 95 confidence interval to indicate prediction reliability. The model compares forecasted life expectancy against actual observed values. Evaluation provides insight into the model predictive accuracy. Okay, now let's go to my model and see how it works. Okay, this is the model I developed. I put some explanation about the parameters for the model, and here you can see I have the path to the data files. I've uploaded all those data files to my GitHub, and you can download it and use them. And I'll build the series and normalize it. This function will select ARIMA order, and you see this function will split data to the train set and to do the fit and the forecast, and plot the forecast. And here you see I have the setting. I run it. In this function, I will compare the forecast to actual data and save CSV. And also I'll plot the model versus the actual data in order to compare my forecasting. Again, I've uploaded my source code to my GitHub, so you can download it and play around with it by yourself. The first time I've used cohort weight 0.5. That means the cohort data will have half of the weight. If we run our model, okay, now it's done. You can see this green line is actual female, and this red line is our forecasting, and this area is 95% confidence interval. And for the male, you see the actual male is this line, and this orange line is our forecasting. If you notice this big dip, this is caused by the COVID-19. So for the female, you can see this area is kind of out of the 95 confidence interval. But for most area, it is inside this 95% confidence interval. If we enlarge this chart, you can see it's something like this. You can see this forecast is using AIC, and this forecast is using BIC. Basically, looks like they're the same. If we check the enlarged graph, this is AIC, this is BIC. So the forecasting results are not affected too much by this criteria. Now, let's change our parameter. If we say cohort weight is 0, let's clean everything here. And run it again. Alright, now it's done. Let's look at the forecast result directly. You can see here, if we use AIC, our forecast is like this for female, and for the male it's like this, and the actual data is like this. You see, this time the whole actual data is within our 95 confidence interval. If we change the criteria to BSE, you see it changed a bit. But still, if we see the enlarged one, the actual data is within. This is maybe a little bit outside, but basically it's within our 95 confidence interval. So you can see this cohort weight has an impact on our forecast result. This is how I built a life expectancy trends ARIMA model in Python. Please comment, like, and subscribe to my YouTube channel. It will definitely help my YouTube channel grow. Thank you so much for watching.